Well, we finally made it to the standard normal distribution. This is where it really starts being statistics. Your standard normal distribution, number one, has to have a bell-shaped curve. And by bell-shaped, think Liberty Bell. It looks something like this. So this is what we mean by a bell-shaped curve. The center of this is mu, and in a standard normal distribution, that's going to be 0. Then you start counting over by the units, which are actually the standard deviation. So that's 1 standard deviation, 2 standard deviations, 3 standard deviations. Going to the left, we've got a -1 standard deviation, -2 standard deviations, -3 standard deviations. And in this case, for a standard normal distribution, not only do we let mu be 0, but the standard deviation is going to be 1. So those are the basic characteristics. You've got a bell-shaped curve. Mu equals 0, that's the mean. Then standard deviation equals 1. The area under this curve is always equal to 1. As in 100%. So the area for the whole thing is going to be 100%. There's the height of the curve at any particular given x value is the same thing as the probability of getting that particular x value. So overall, once again, if you took the probability of every single possible x value, every single line here, and put them together, you would still get where the area is equal to 1. And the area is the same thing as the probability. So the probability of getting something in here is going to be 100%, the total area. If we look at, let's say we want to look at the probability of getting something from this x value up to this x value. To get the probability of x falling between x1 and x2, or the area that falls under the curve between x1 and x2. Well, we've looked at the empirical rule before. Remember, the empirical rule says that if you go out 1 standard deviation, you're going to pick up 68% of the data. If you go out a 2nd standard deviation, altogether, you're going to have 95% of the data. And if you go out a 3rd standard deviation, and notice that the standard deviations are all equally spaced, but the amount of area under each new section becomes smaller and smaller. So from 3 standard deviations to the left and the right, you've now got 99.7% of the data. Now these are approximate, they're estimates. In order to find a probability of an x just randomly anywhere in here, we either have to use technology or a table. And we're going to do it using technology. We're going to do this with StatScrunch. go to question help, pull up StatScrunch. There's nothing in here giving me anything I can download into StatScrunch. So what you do, go to Stat, write this down, Calculator. This second menu might go on the left or the right, but locate Normal. So we're using the Normal calculator. Let me just slide this all the way over. Okay, so it comes up, it defaults to the middle with a mean of 0, a standard deviation of 1. If we want to know the probability that the x is less than or equal to 0.63, then I'm going to type in that z value, compute, and here we've got 0.7356. We have the option of putting less than or equal to or greater than or equal to. If we change this to greater than or equal to this part up here, it's going to actually give us the complement of the other, 0.2643. Notice that the other one, when I had less than 0.7356, this is rounded off, and so it actually adds up to 9999. So that's a rounding error. A rounding error amounting to 1 10,000,000, 10,000, 1/10,000th of a decimal. So let's clear these and look at a couple more. Now, I'm not even going to close this because I can probably use this on multiple problems in here. This one has a negative z-score, and they want us to find the area to the right of that. So the mean is still 0, standard deviation is 1. That'll be true for this entire section, but not the next. But my z-score, I want to go to the right. And my z-score now is a negative 0.87. They'll put z-scores into 2 decimal places and the probability, the area, into 4 decimal places, typically. 0.08078. So this is about 80%, which makes sense because this is a little farther from the mean than the other one was. On this one, they didn't color it in, but they're, rather than giving us the z-score, they're giving us the probability. So the probability over here is 0.09292. Didn't give us the z-score. This is what we're looking for. Find the indicated z-score. So since they gave us the probability, the area, instead of the z-score, what I want to do is come down here, and in place of the area, I want to put 0.9292. This is going to be a less than. So the z-score is 0.14698, so 0.1470. 69 gets rounded up to 70 because of the 8. This problem says, assume the thermometer readings are normally distributed with a mean of 0 degrees Celsius and a standard deviation of 1 degree Celsius. A thermometer is randomly selected and tested. For the case below, draw a sketch and find the probability of the reading between 0.5 and 2.25. Okay, this is a between. Both of these are positive, so they are both to the right of center because they're both positive values. Remember that any z-score to the left of the center is going to be a negative. So this has to be this one right here, between 0.50 and 2.25. Over here in my calculator, I want to go from standard being lit up to between. The one that is light, the one that has a white background, is the one you're using right now. So notice that the between, all of a sudden I have an area that it has two boundaries, one on each side. So the mean is still 0, standard deviation is 1. Now this is the area from a -1 to a +1. Recall that we used the estimate for the area between one standard deviation above and below the center was 68%. This is actually giving us 68.26 blah, blah, blah %. So to calculate the area that falls between z is 0.5, this is actually going to be written as between 0.5 and 2.25, we would write that 0.5 is less than or equal to z is less than or equal to 2.25. So when I come down here, I'm going to put the first number in as 0.5. I'm going to enter the second one as 2.25. And when I hit compute, notice that this graph matches the one in my MATLAB. And the given area, the probability and the area are exactly the same thing. So to 4 decimal places is 0.2963, since the one just drops off. This problem gives us a percentile. We've still got a mean of 0, standard deviation of 1. A thermometer is randomly selected and tested. Draw a sketch and find the temperature reading correspond to the 80th percentile. Recall that this is the temperature reading separating the bottom 80% from the top 20%. So if I come over here, I'm going to put this back for just one reading. In my probability here, I'm just going to put 0.8, same thing as 0.80. Compute. So the value that separates the bottom 80% from the top 20% is 0.8416. Since this is an X value, we're going to round it to 2 decimal places, so 0.84. Now this notation, this is Z, an alpha, where the alpha represents the area above the Z value, or the area to the right of the Z value. Everything else has mostly been areas below a given value. This is going to be above. So what we want to do, the 0.02 means 2% of the area is above that Z value. And therefore 98% is below. But we can just come over here and set it at greater than or equal to make it above. Set this at 0, 2. And the z-value that corresponds to that is when z is 2.05. So slightly more than 2 standard deviations above the mean. So that's how we're going to use StatScrunch to calculate standard normal distributions and probabilities. It's super easy with StatScrunch.